Okay, this is 3a. The function f is differentiable on the closed interval. Let's see, 1, 2, 3, 4, 5, 6. Okay, that makes sense. Be slow and careful. 1, 2, 3, 4, 5. Okay, we're good there. F of negative 2 is 7. Now be careful. This is f prime. But the value of f when x is negative 2 is 7. The graph of f prime, the derivative of f, consists of a semicircle. Read slow and careful. And 3 line segments. As shown. Find the value of f of negative 6 and f of 5. Well, one thing at a time. So because I have f prime and I'm trying to find f, that's the fundamental theorem. So if I integrate f prime, that will give me the difference in two f values. I want to involve an x-coordinate of negative 2 because we know the value of f when x is negative 2. I'm trying to find the value of f when x is negative 6. So I'm going to integrate from negative 6 to negative 2 because I don't want to integrate backwards, which means the negative 2 belongs here and the negative 6 belongs here. That's the fundamental theorem. Rearranging to solve for f of negative 6, I'm going to end up with this integral here. The integral from negative 6, well, that's where I started. I guess I was showing more than I realized. So that's where I start. I plug in this value, that's my 7, and then I rearrange. So that gives me this integral here, or this equation, I should say. If the grader can see that you are remembering to include the 7 in your computation, you get 1 point for remembering that. I've got to now find the value of this integral. Let's erase this. I've got to find the value of this integral. So as always, when I have a graph, I start at negative 6. I draw a vertical line. I go to x equal negative 2. Draw another vertical line. I'm integrating f prime. And so now the area I'm concerned with is this triangular area because it's the area between the horizontal axis and what I'm integrating. That's 4 wide and 2 high. That would be 8, but half of 8 is 4. Therefore, that area is 4. Therefore, the value of this integral is 4. So then 7 subtract 4 gives me 3. So the value of f at x equal negative 6 is 3. 1 point if the grader sees that you're using the initial condition. 1 point if you correctly tell the grader the correct value of f of negative 6 as being 3. Another way to think of this is the graph of f is not known. You do know that when x has a value of negative 2, the y value of f is 7. So negative 2 comma 7. And you know that when you integrate f prime, you discover how much f changes. So this integral of f prime from x equal negative 6, so that would be over here, to x equal 2, that integral of f prime tells me how much f changes from an x-coordinate of negative 6 to an x-coordinate of negative 2. So the value of the integral was 4. That means that because we ended up with a value of f of 7, we must have had a value over here of 3. Because all of these values of f prime are positive from x equal negative 6 to x equal negative 2. Therefore, f is definitely going up some way. And f's got to go from a y-coordinate of 3 to a y-coordinate of 7 because the integral's value was 4. The integral's value tells me how much f changes from this y-coordinate to this y-coordinate. So 2 points so far. We're supposed to find f of 5 as well. I would do the exact same thing. Create an integral. Plug in our value for f of -2. Make sure we're going from left to right. Now when we rearrange, f of 5 becomes 7 plus. We've got to find the value of this integral. So this integral starts at x equal -2 to x equal 5. Therefore, this area here will be counted negatively, and the area here will be counted positively. So this is a semicircle. The area of a semicircle can be found by taking pi over 8 multiplied by the diameter squared. So that's pi over 8. The diameter is 4. 4 squared is 16. 16 divided by 8 is 2. So I figured out that the area of that semicircle is 2 pi. So the area here is 2 pi. I'm going to count that negatively in my integral. The area here, this is 1 wide by 2 high. 1 times 2 is 2, half of that is 1. Then 2 times 2 is 4, half of that is 2. So this area is 3. There I have the 3. The area of the semicircle is this, which again is simply 2 pi. So now we just add them all up. Again, this one counts negatively because it was area that was below the x-axis. So we have the 7, subtract the 2 pi, plus 3 more. That's why we get 10 subtract 2 pi. You don't have to simplify. You could stop at the blue box to earn that third point.